And then finally, determine the energy efficiency level. That's again comparing to other facilities of similar size and use. So now talking about the walkthrough audit, there's a few pieces to that. First we start off with a client interview. We have a survey that it will be available to any of you guys following the Steve Salzberg, as part of the EcoVentions, will be providing a version of the survey so you guys can have access to that. We know you do the walkthrough inspection, so you're looking at the facility, the walls, the windows, the attic, the basement, and all that, determining the insulation levels. You're inspecting your building systems, and the main building systems that we focused on were the lighting, the appliance, plug load, the VHW stands for domestic hot water, and your heating and cooling systems. And another important part of an energy audit that a lot of people don't know about is the fact the health and safety aspect of it. Combustion equipment, like boilers and hot water systems, those are releasing fumes into your facility, and you have to have proper ventilation for that. As well as water leaks and moisture buildup and all that can lead to health hazards. So those are things that we also look at during an energy audit. And finally, we come up with recommendations and put together a report. Oh, I think I skipped the post audit. So after you put together your report, effectively you go back and you present it to the business owner, and you answer any questions, and then you really try to help them identify what incentives would be the most applicable. So now moving on to the actual walkthrough audit, I'm going to go into a little bit more detail on that. So as I mentioned, after the client interview, the next thing we're going to do is do an inspection of the interior and the exterior of the facility. What we're looking at here is, again, moisture, mold buildup, things like that, fire hazards or VOCs, volatile organic compound pollutants. You want to determine if there's any health and safety hazards right off the bat, because those are probably, those are very revealing. From that, you can determine, is there a water leak, is the AC not functioning properly?
Just aside,
I'm sorry?
on the side, if we want to talk later, on the moisture problem, mostly in New York it's leaks and whatnot.
Right.
As I look at more insulating, you can create moisture problems through insulating. And you find that, have you addressed that quickly or?
Well, exactly. So that's part of what you have to balance, right? You have to balance the infiltration of and exfiltration of the air and moisture buildup. So I mean, you want to find that balance of how tightly you conceal versus how much certain ventilation you need in the space. And I mean, there's codes and standards for that kind of measurement, and you basically have to follow code. So the thermal inspection includes looking at walls and windows, as well as doors. And is everybody familiar with what an R value is? Is anybody not familiar with what an R value is? So an R value is the resistance value. It's how well any material insulates. So walls, windows, they all have different R values. The larger the R value, the better the insulation factor. Single pane windows have a smaller R value than double pane windows. Although for windows, they use a different value called the U value, which is the inverse of the R value, but it's a little complicated. Point is, everything's got a resistance measurement, and you obviously want to increase that. Okay, yeah, so this is where you're looking. This is what you're looking at with regards to your inspection. Air will seep through any crevice in your facility. So even something like your lighting outlet or your lighting fixtures, all those, if they're not properly sealed, are opportunities for air to escape. So it's important to identify all of them and seal them properly. So now moving on to the building system inspections with regards to lighting. Effectively here what you're doing is taking inventory of all your lighting equipment. So you're going out, you're counting light bulbs, You're determining what different types of bulbs you have. So here we have some fluorescent tubes. Nothing else really. But you take inventory, you record the number of hours that it's used, the number of days that it's used, and all that will lead you to an end number of energy consumption. So you should be able to determine how many kilowatt hours a month or a year you're using for lighting, and from that you can determine how much that's costing you. It's also important to determine the number of circuits because that will determine how many sensors you'll need for different facilities, if that's what or different spaces, if that's something you're looking at. With hot water, you want to that's fine. So with hot water, you're going to want to record the manufacturer, the model, the fuel type, as well as make sure that there's proper venting. And then you want to know the condition. And any hot water older than 10 years is that's recommended to be replaced. That's kind of a rule of thumb. And you also want to check the set point. You want to check the temperature that the water's set at. A lot of times, hot water tanks and hot water systems will be set much harder than they need to be. Typically, about 130 is recommended.
Excuse me. I don't know. This is. I'm talking at home. My water heater. All it is, like you say, 130 is too high. But the setting on my water heater at home has low, medium, high.
ABC.
Huh?
ABC.
Yeah.
There's ABC in there.
Just says low, medium, high. So where's the 130? Do I just set it to low or?
Yeah, no. So not all of them will have the degrees. So for that, you probably set it on medium, and if that's not working. I mean, unfortunately, that's just not as accurate as the other.
Just feel okay, because I don't know if I'm wasting them that if I turn it down, it's going to be
Put it on C and find out when you run out of hot water. If you're not running out of hot water, good.
All right. Well, we actually only have about 10 more minutes for this session, so I'm just going to skip up to the energy conservation measures because we'll actually end up going through most of this stuff in this conversation as well. Yes, unfortunately, none of my pictures came out because I was using a Mac, but some of them did, fortunately. So with regards to lighting, we focus on 4 solutions, 2 of which are right here. The first one is really straightforward. You guys have heard it a million times. Replace your incandescents for CFLs. I can't overstate how important that is. I mean, it's so simple and it's so easy and a no-brainer, but people really still haven't done it. And it's unfortunate because for every light you replace in a typical business, you'll save about $20 a year. I use it as a rule of thumb. Light may cost you $2 to purchase, and so it pays itself back, in 1/10 of the year, and you're saving 20 years per light per year after that. So that's substantial. And also, secondly, replacing T12 fluorescent tubes with T8s. Fluorescent tubes, like the ones you guys see everywhere, they come in different sizes, and the sizes both in terms of length and in terms of girth. The T12 here represents the diameter, 12/8 of an inch. So that's 1.5 inches in diameter. It's kind of awkward, but yeah, so it's 12/8 of an inch. Those are the ones that you see in all the subways. Those are the ones you see, the most common ones, T12. Those can be replaced by T8s or T5s, which are accordingly 8/8 of an inch or 1 inch in diameter or 5/8 of an inch.
Is there a T4?
There are some specialty lights, and I've seen T4s, T3s, but those aren't common. Really, the ones you see are T5s and T8s.
And you're just replacing the bulb, not the fixture.
Yeah, well, actually, that's a great question because T12s, fluorescent lights, unlike incandescents, require ballasts, which are like these boxes that you see that essentially calibrate the voltage and the frequency of the voltage and amperage to allow for the light to come through. So T12s use they use magnetic ballasts, which are less efficient than electronic ballasts. And when you replace from a T8 to a T12, you have to replace your ballast as well. That's an important thing to note, not only for practicality purposes, but also because there'll be energy savings associated with the ballast upgrade as well. If you were to keep a T12 and replace just the ballast, you would see savings just from that.